So in this video, before we even could talk about the reactions of ketones and aldehydes, we need to know how to make them. Okay, so if I take a simple alcohol such as isopropanol and I add bleach, okay, it's an oxidizing agent. I could use also potassium permanganate, or I could even use PCC. But anyway, I'm gonna get the ketone. I'm gonna oxidize it to a ketone. Okay. Now, what if I take this? Okay, what if I take a tertiary alcohol and I use bleach or any oxidizing agent? I get no reaction. Okay, so tertiary alcohols we cannot oxidize. Now, if I take a primary alcohol and I don't know, let's use PCC. Okay, we get the if I take a primary alcohol soft oxidizing agent, we get the aldehyde. Okay, we get the aldehyde. Okay, and we know PCC this degenerates into some sort of it's a benzene ring with a nitrogen. Nitrogen get a plus charge, and I'm using CO3 minus. CO3 minus 3 should be down there. Okay, so that's the reaction. So the general pattern is from primary alcohols, we get aldehydes. From secondary alcohols, we get ketones with oxidization. Okay, with tertiary alcohols, however, we get no reaction. Okay, so these are the ways we make ketones and aldehydes. Now there are also several different ways that you actually learned in your first semester of organic chemistry 1. So if we take an alkene, okay, and we add O3 in dimethyl sulfide, or DMS, okay, we'll actually cleave the bond, and we just replace each end of the bond replaced with an aldehyde. So therefore we have 1, 2, 3, 4, 5, 6 carbons. So if I'm looking at this, I have 2, 3, 4, 5, 6. I have my aldehyde, and I have my aldehyde here. Okay. Now simultaneously, if I take this molecule here, okay, if I take this molecule here and add O3 in DMS, okay, I cleave my bond. Okay, in this case, I'm going to get a ketone plus I have an H there, so I will get the aldehyde. Okay, and this portion is just drawn a different way. So those are a couple of the ways that we make aldehydes. Now, there's another very important one that we need to know, and it's the chemistry of alkynes. Okay, so if I take, it so happens that if I take this molecule, and it could be any alkyne, but it has to be terminal though. Terminal, okay, so let's do terminal. If I take any terminal alkyne and I add this reagent, AgSO4 and sulfuric acid and water, what I'll do, I'll get the ketone product. So on the carbon, on the third carbon, I'll get my ketone product. I'll always get the ketone product on the internal carbon, not the one closest to the hydrogen. So I'll get this product. Okay, I'll get a ketone. Okay, so that's a reaction that is for us to very important to know. And let's look at one more example. So what if we took this reagent? Okay, what if we took this alkyne? Okay, let me get some focus here. So what if we took this alkyne, okay, and we added AgSO4 in sulfuric acid, okay, and water? What I will get? Well, for me, I'm going to start counting carbons. So to me, it looks as if I have 1, 2, 3, 4, 5, 6. So on carbon 5, on the internal carbon, I get my ketone. So we have 6 carbons. So 2, 3, 4, 5, 6, and there goes my ketone. Okay. Now simultaneously with the same molecule, okay, if I take an alkyne okay, terminal alkyne, and I add borane, okay. So if I add borane and hydrogen peroxide, I get the aldehyde. Now I'll get the aldehyde on the terminal carbon. So this becomes this, and I get my aldehyde on terminal carbon. So you could see 1, 2, 3, 4, and then the terminal carbon we get 1, 2, 3, 4. So on the terminal carbon we get the aldehyde. So notice the difference. On the internal carbon we get the ketone. On the terminal carbon we get the carbonyl. Okay. Now what does borane looks like? It looks something like this. It's a boron. The molecule looks something like this. It's pretty interesting. Okay. So the molecule looks something like this, and usually you'll see it as dibol. Okay, and these are usually capitalized. You usually see it abbreviated as dibol. Okay, so just remember that whenever we use dibol in an alkyne, we get the aldehyde.